Dear all, greetings of the day. I'm Dr. Abhishek Pandey from ABES Engineering College. I am Assistant Professor in Department of Mechanical Engineering. I will be taking series of lectures on shear force and bending moment diagrams. The very first lecture in this series will be Introduction to Beams. Now, the very first thing which we need to know is what are beams. Beams are elastic structural members that are primarily resisting the loads which are acting on the lateral axis of the beam. So when a beam is loaded, it is deformed. This deformation is generally called as deflection. When load is applied on beam, it results in reaction at the supports. And because of this reaction at the supports, we are experiencing shearing forces and bending moments in the beams. The shear force and bending moments in turn induce internal stresses, strains, and deflection of the beam, which we'll study in our subsequent topics. So we can classify beams according to equilibrium conditions, according to cross section of the beam, according to material, according to support which is acting on the beam, or according to support on the beam. So the very first thing which we need to know is that beam can be horizontal as well as vertical. The only condition is that it should support load on the lateral axis. If it is supporting load on the vertical axis or longitudinal axis, we call it as columns. So as we have discussed earlier, the very first classification of beam, it is according to equilibrium condition of the beam. So we already have studied equilibrium conditions, and that equilibrium conditions is that all the horizontal forces which are acting on the beam should be summation of all the horizontal forces on the beam should be zero. Similarly, summation of all the vertical forces which are acting on the beam should be zero. Summation of all the movements which are acting on the beams should be zero. So if all these three equilibrium conditions are satisfied, then we call that type of beam as a statically determinate beam. It means that all the unknowns can be easily calculated. If it is not possible to calculate all the unknowns which is required to calculate from given number of equations, then we call that type of beam as statically indeterminate beams. Examples of statically determinate beams are simply supported beams and cantilever beams. If number of unknowns are more than number of equations, then that type of beam is called as statically indeterminate. And the examples of that type of beams are continuous beams, fixed beams, and we will be studying all these types of beams in detail in our subsequent lectures. The second classification is according to the shape. We can have beam of rectangular, circular, or any other shape which is required by the design or required by the look of that particular thing which we are designing, and with the help of beam which we are supporting. So we have these type of shapes which are generally available for structural members: I section, C section, L section, T section, hollow section, which can be circular and rectangular both. And we can have solid sections, and that can be circular, rectangular, and it can take any shape according to the requirement. So we can have another classification, which is according to the material of the beam material in the primitive stage, we were using wooden logs, so it was generally circular, so it can be circular, we have already discussed. But now with the advancement of technologies, we are using instead of wood, we are moving on to concrete, we are moving on to bricks, we are moving on to other timber materials, and we are again using fortified beams also, which is generally called as composite beams, in which what is happening is there is a timber which is there. I mean, timber means wood. Rectangular wood is there, and it is fortified at the ends with the help of some steel, and then that type of beam we are calling it as composite beams. Any material can be used as beam depending upon requirement, depending upon availability, etc. So the most broad classification of beam is according to types of support. So the very first beam is of academic importance is simply supported beam. Simply supported beam is supported at the ends. It is free to rotate, and it has no movement resistance. So this is this type of beam. If you see here, what is happening here in this case is that this particular beam is not fixed here. So it is only kept on this particular support. And this is free to move in any of the directions. And it is free to move or rotate in any of the directions, that is clockwise or anti-clockwise. This is the very common example of simply supported beam, the bridges which we are seeing. And next type of support, next type of beam according to support is fixed beams. And this fixed beam, what is going to happen, that this particular end is also secured, and this particular beam will not be moving. I mean, it is not free to rotate in fixed beams. It is restrained from rotation. So if this beam is something like this, and if you see this, here what we are doing here, we have clamped this beam. This is I-section beam, and we have clamped it with the column. So we can call this type of a structure or this type of beam as fixed beams. Another classification, another type of support is overhanging beam. In this, what is going to happen? One end of the beam is extending beyond the support. So this is simply supported beam, and what is happening? This end is being extended, and that's why this is called as overhanging beam, because it is hanging at one of the end. We can have double overhanging beams. In this, what is going to happen is that simply supported beam, which is overhanged on both the ends. So this is the example of this type of beam. We can have continuous beams also, in which what will happen, that we may have one, two supports are here, and we can have one more support, and we can have many number of supports in series. So this is one example in which we have, this is a continuous beam. What is happening here? Here we have one support which is fixed, and then we have two simply support type of supports. So this type of support will be called as continuous beam. We can have another variation in this. This variation is something like this. Here we have three continuous supports here, and we can have n number of continuous supports. And this type of beam we will discuss in our future studies. So another type of beam which is very common is cantilever beam. In this, what is happening is that one end is fixed and another one is free. We have another type of beam which is called as trussed beam. In this, what is happening is we are adding extra rods and extra structure to secure the beam. So this type of truss structure is also called as trussed beam structure. So according to load on the beam, we can classify beam according to load also. So point load, in this, concentrated load is acting at a point. Example is something like this. Simply supported beam, point load is acting at C. And we can have distributed load. This distributed load can be of two types. In fact, can be of three types. One is uniform distributed load, means per unit length of that particular load is fixed. And then we have a variable distributed load, in which it is irregular, it is not fixed, but it may be fixed regularly. So this type of load in which it is varying at some particular rate, it is increasing, and this one you can decreasing. If you are seeing from here, it is increasing per unit length, and from here also it is increasing per unit length. But if you see from C, it is decreasing per unit length, and from C, if you see, this is decreasing per unit length. Another type of load we can have in distributed load is a regular load, in which we can define the profile of the load with the equation. And the example of this type of load can be seen here. Just see here what is happening is the load is varying, and it is varying according to the equation of this line A, B. So we have a profile, and load is according to the profile. So this is the classification of beam according to the type of load. I hope introduction to beam is done, and everything will be clear. And if you have any questions, you can discuss that particular question with me. You can have a movement load also. In this case, the example of this type of loading is this. What is happening here is this 50 kilonewton meter load is acting on the beam. It can act here, it can act here, it can act here, it can act anywhere on the beam. So this can be clockwise, this can be anti-clockwise, and so on.